we get started? Can I really quickly just ask for a show of hands, how many of you saw my talk in Berlin at .fmp? Okay, so not very many of you. The reason I'm asking is that this talk is largely based on the talk I gave at .fmp. However, it has changed somewhat since then. There are additional things, and it's quite a fast pace. The rate of change is quite remarkable. So anyway, I hope will still be worth your time to sit and watch. Okay, I'm Ian Jempson. Basically, grew up in Canada, but I've lived in central London for the last 20 years. Worked with FileMaker since version 3, and I primarily started working with AI when I went back to school and did my MBA a few years ago, where I wrote my dissertation on strategy and AI. Then since then, I basically spent most of my time, or a great deal of my time, writing code that actually implements those ideas. So, and I've been working on a product called insightsformeetings.com, which basically, if you saw Douglas's presentation this morning, he basically demonstrated a number of things that actually I'd written and implemented, so that was interesting. Anyway, very rough outline. We're going to start off just by talking about sort of what are large language models, and that's kind of important because it looks at a bit at what are the constraints and what are the limitations on them. Then most of it's going to be on integrating your FileMaker data with LLMs, and I'm going to be looking at both OpenAI and also local models. And then sort of what are some of the considerations around this. So about a year ago, OpenAI released ChatGPT, and a year later we've now got OpenAI, we've got Anthropic, Meta, a load of open source models. Bloomberg have got a finance LLM, and there's a number of special purpose models. So it's just exploded. The rate of pickup of the technology has been incredible, and the rate of change as well. So the landscape basically, just generative AI landscape, covers a wide range of things: text, images, audio, video, code. It's remarkable. So mainly we're going to be talking about LLMs and Claris. And while Claris Connect can connect to these things, I've actually not got any demos of Claris Connect. So the demos are basically going to be substantially FileMaker talking to LLMs. Some of the things I'm going to say are basically, in a couple of areas, are going to be kind of maybe oversimplifications, but the underlying point is still valid. So they may not be strictly true, but they're broadly speaking true, and you can use it as a useful model for how to view things. So OpenAI provides a large language model, and that kind of underpins ChatGPT, and there's a large number of other models as well now. So ChatGPT is a chat product that's built on top of the large language model, so they're not the same. It's quite easy to confuse them and conflate them. And actually, OpenAI are not helping this a whole lot with some of their recent naming, because they've named one of their recent products GPTs, which is the same term for the underlying technology. So that kind of stuff is quite confusing. So the LLM is going to be built. It's built on top of a neural network, and GPT, the original term, is a generative pre-trained transformer, which was invented by Google. And this is what the architecture looks like. Not that you're ever going to actually be working with that directly, but that's kind of the architecture that, when they invented it about 7 or 8 years ago, has changed everything. And it largely came out of this paper called Attention is All You Need, from Google and the University of Toronto. So that technology has been applied substantially by OpenAI. Google was really quite upset by this, because this technology they largely invented has been popularized and commoditized by other firms, and they're left a bit behind at the moment, and they're not really sure how they're going to compete. So if you look at what is a large language model from a different perspective, It's a probability distribution over a sequence of words. And a really good description is that it's always trying to produce a reasonable continuation of whatever text it's got next. So it's as if it's just trying to predict the next word again and again and again. So if we say once upon time, it's just predicting the next word in the sequence. That's fundamentally what the base models are doing. Then on top of those base models, we've got fine-tuned models that are tuned towards specific tasks, but that's fundamentally. Another example would be fourscore and if you're an American, you pretty much know what the next word in that sequence is going to be, whereas when .fmp, when I showed that, none of the Europeans did. So it kind of shows that this kind of thing is context sensitive, depending on where you are and who you're speaking to. So it's a model reality, and it's a statistical model. So it produces text that plausibly matches the input. The answers tend to be really, really highly confident and plausible sounding, even when they're wrong. It's been trained up to a specific date, and it can't answer questions after that point. Earlier this week, OpenAI had their OpenAI Day, and they've announced that they've moved on the date where the models are trained up to. So it's basically prone to what they're referred to as hallucinations, where it can make things up that sound really, really plausible. So it's not superb with factual information unless you guide it. And to use our own data, we need to use some specific techniques, and I'll sort of kind of cover over what those are. And just before .fmp, I was writing a FileMaker script, and I needed to know whether the currently open window was a card window or not. I had ChatGPT open, so I asked it. And this is basically what it said. Really helpful answer. Told me which function to use, told me what the function returns, gave me a little script sample, which is absolutely brilliant. I thought, that's great. And so I went and I typed that into the data viewer. And there's a minor problem with this. There is no FileMaker function get window type. It basically made it up. So get window style is the correct function. So I asked ChatGPT about that. And here's what it told me about that. Gave me the 6 results that it returns. And there's another minor problem here. I see some people shaking their heads. And on the right is what Clara says get window style returns, and on the left is what ChatGPT says it returns. And they're quite different. But the thing is that what ChatGPT returned was so plausible sounding, I just basically didn't even question it. I just started typing this in the script editor to move on ahead. So there are constraints and limitations, and you can't really 100% rely on everything it says. But it's just worth bearing those constraints in mind when you're using it and applying it. So with FileMaker integration with OpenAI, there's really 3 methods we can use. There's prompts. Actually, I should prefix this by saying that we're going to integrate, the integration is going to be via the insert URL. So we're using curl to do this. So within that constraint, we've got prompting. We can put prompts in to request the data. We've got retrieval augmented generation, or RAG, and then we've got fine-tuned models. So those are the 3 broad categories. So with prompts, we feed in the data and the questions, and as Douglas said earlier, you need to be careful about the number of tokens. Tokens correspond very approximately to words. They're not exactly words, but they're kind of units of meaning as far as the LLM is concerned. And then you've got these size limits. So different models have got different size limits of how much text you can feed in one chunk. And if you've ever tried to feed in, say, 20,000 characters into ChatGPT, you'll probably find it tells you can't do anything with this. So if you've got large quantities of text you need to feed in, we need to be very, very careful about this. And that's one of the things, as Douglas said, that they're going to be working on trying to resolve. Other systems say in Python, for example, there's a system called LangChain, which basically provides abstractions for all of this and can deal with chunking up the text into appropriate sizes so it can feed things in correctly. The next approach is retrieval augmented generation, and what we do is we query the data somewhere else, we pass that in to generate the output text, and that uses vector databases as a means of doing that. And then the final one is fine-tuning a model, which uses transfer learning to retrain an existing model. You can use your own data, but the data quality and quantity are really, really important. The other thing here is that actually fine-tuning a model can be quite difficult. I decided that I was going to fine-tune a model showing the conference attendees, so I could ask questions about, I thought that'd be a great demo, ask questions about the conference, and it turned out to be much more difficult than expected. So actually, there is another approach, and that is pre-training, which OpenAI recently said in their case that for really large corporates, they could do pre-training of new models, but the cost in that case, they were talking about charging in the millions of dollars. So I'm kind of assuming that most of our budgets don't stretch to millions of dollars to retrain AI models. So we'll just look at those other examples. So I'm going to assume that everyone here knows how to deal with insert from URL into to curl to an API. This is one of the APIs that OpenAI provides, and that's kind of a really simple example of the what the call would look like. However, with their changes this week, when I tried that, I noticed that I got a message in my response saying that endpoint is being deprecated in January. So essentially, code that I wrote about a month or so ago basically is going to have to be rewritten before the end of January. So the pace of change is really, really fast, and I found that as well with LangChain in Python, that they're changing stuff really fast and things are breaking. So we need to kind of bear this in mind when we're doing integration. So if FileMaker are able to build something into their product that kind of does this, that's going to be really nice because they can worry about that side of things breaking, and hopefully they'll be able to deal with it. So if we start with an example, what we can do is we can ask OpenAI of what models it can use. And so there's an API call for that. So I just do that, and it gives a list. And there's a surprising number of models. Down at the bottom of the list, we've got 3 models these are fine-tuned models that I've trained. So with the prompt engineering approach, I'll just give, Joris is going to be talking about querying ChatGPT and OpenAI, so I'm just going to be really, really quick on this stuff. But with prompt engineering, we want to be really, really clear and specific on what we're asking. If we can delimit the different parts of the prompt, that's really, really helpful. Asking for structured output is another good thing. Asking it to examine its assumptions. And then few-shot prompting is providing examples of what we're passing in and what we expect to receive. And those kinds of tools can help give better results from prompts. Giving the prompt time to think by asking it to clarify the processes it's going through is also another helpful approach there. And if you sort of say which steps you want it to take, then that can also be very helpful. And asking it to work out its solution before coming to a conclusion is also good, because sometimes they will do what people do and just jump to a conclusion really, really quickly. And like people, that is frequently wrong. So just want to be really clear about what you want in the end. It's also a very iterative process. And if you're integrating with FileMaker, it's really handy just to try it out in ChatGPT and look at the different different questions you're asking and see and try a number of times until you kind of converge on something that gives you what it looks like you want. So in this case, I'm going to show a demo of asking about conference attendees. I'm just going to pass in the data in the query. So what I've done is I basically got a query. I've got a big long list of all the conference attendees that I'm passing in the input. And in this case, I'm running that through OpenAI. And you can, the question I asked was how many people named David were attending the conference. Like OpenAI came back with the correct answer of 5. And then the second thing I'm doing is I'm running this on a local model, and this is a model that was running on my MacBook. And it's come back, and that model is named Mistral. And it's basically said there's only one attendee. So it's come back with a wrong answer, but the other thing that you noticed probably is that ChatGPT was really, really quick at coming back. That very, very fast, whereas Mistral had to sit and think and work quite hard at it. So it took several seconds running locally. And one of the main reasons here is that large language models rely very heavily on GPUs, graphics processing units, to do the number crunching. Most of the local models are not able to take advantage of the GPUs on a Mac M1, M2, or M3 processor. If you're installing via Docker containers and are willing to do a whole load of messing around, you can get them to do that, but it's quite tricky. So that is kind of an advantage of OpenAI in that regard. That's faster, and it's also generally going to give the highest quality results. So what's happening here is basically from the database, from FileMaker, we're sending the query to the LLM, which is then calculating a result and then returning the result as JSON. So in this case, the LLM could be either OpenAI or the local model in that case. The next example I'm going to show is basically I'm asking it to edit the FileMaker database schema using OData. So what we're doing, you can see here that we've got 2 database tables in this example file. And if I just run it, go back, and I'll try to pause it at the right point there. So I'm asking it to define a database schema for and I've basically given it an example of the format that I want it to return it in. So, and this one you can see does take a bit longer running on OpenAI. I've not tried running this one on a local model. As you can see, you get the URL data transfer dialog. That's something that Claris, I believe, are trying to avoid, having these dialogues saying, Mr. Watson, you look like you're puzzled.
What did we just see? It just flashed up a database definition and the tables are in there, or?
Yes. So what
happened? How did you do that?
Okay, how did we do that? Well, this is how we did that. No, so what I did was I basically I basically took an example of the JSON that you would pass to OData. I passed that into the model as an input, said, this is an example of what I want. Define a schema that is a basic contact management system. It handed that off. OpenAI basically said, okay, here is an example of what you want. It knew how to build that JSON. It returned that JSON to me. I extracted it and then fed that into the OData API within FileMaker. So that's kind of what happened there. I'm sorry, I'm trying to do these pre-recorded because OpenAI's they've been suffering denial of service attacks in the last week, and they've been up and down quite a bit and can't necessarily be relied upon. The demo slides are not yet on the thing because They were finished last night. But they will be there, and I'll also I'll extract the examples into a simple FileMaker file that you'll be able to download as well. So the next one I'll show here is just generating SQL. Now, Douglas showed an example of this, so I'll just but essentially what we're saying, the first part here, what we're trying to do is set the context or the expectations for it. We're saying that if you ask the model to act as a SQL expert, it knows better how to generate SQL. There are actually now models that are specifically trained to generate SQL, and they're useless for anything else, but they're pretty good at generating SQL. So yeah, I've just asked it to create a SQL-like query given the database schema. Now, the other thing you can do in FileMaker is in FileMaker, you can ask FileMaker what database schema is in the table you're looking at. So you can then take that schema, pass that into the model, and then you can query against your FileMaker database. Or rather, you can generate a SQL query that will query your FileMaker database. So if I just run this one, and I've run this one on both OpenAI and Mistral. You'll notice the more complex ones take a bit longer. Particularly with Mistral, so that's just... If I go to the result, and you can see we've got 2 different SQL queries. They're actually pretty similar, but they're not exactly the same, and they've taken different approaches to that. So that's kind of an interesting approach. And if we look again, what we're doing here, we're from the database, we're issuing a query with our prompt to the LLM saying which builds a SQL based on the schema and then returns. And then in FileMaker, you could actually just run that database query to return a found set. And then, so once you've got the query, you can do what you want with it within FileMaker. I'm just going to move over to FileMaker here because this, what I'm doing is I'm going to use another example where I'm going to take images or an image, and we're going to extract structured data from that image. So this will work with an image. You could do it with PDFs as well. So any number of things. If I just jump over. So what I've got here is, I did this for .fmp, so I just took screenshots of all the session descriptions in .fmp. So I've got Fabrice's session on audit logging. It's an image in the container field. What we're going to do is use FileMaker's getLiveText function to extract the text from that image. Then what we're going to do is going to pass that into the LLM to query that, and then we'll get the LLM response. And from that, because we're asking for structured text, the query here is basically saying, give me JSON data in this format. And that's what I expect to get back. And when I get the JSON data back, then obviously we can just use the FileMaker functions, parse it, and do whatever you want with it. So this one does take a little bit longer. I suspect if I ran this against the local model, that it would take quite a while. Because even OpenAI seemed to have to think for a bit when I did this one. So the LLM response, kind of messy, but if we look at JSON, oh, okay. This is why, see, people are leaving because I've if it's not even going to work, then this is why we do recorded demos. Give 1 second. I'll see if it's something super obvious. I'll fix it. If it's going to take more than 5 seconds, I'll just leave it, because there's another broken demo coming up as well. But the brokenness of the next demo is actually quite instructive and interesting. So I decided to leave it that way. It's, yeah, I'm not going to mess around in a FileMaker script live trying to debug it. Okay.
Is basically the problem that it's not delivering legal JSON back, or?
No, that did return legal JSON, but my function to extract the JSON was incorrect, because the different models are returning in slightly different formats. So they're nesting the JSON slightly differently. So that's why. Okay. But basically, this is what's happening here. So we've got the image in FileMaker. We use the FileMaker getLiveText function to get the text from the image, insert from URL, does a curl to the LLM, extracts the structured data as JSON, which then comes back as data in FileMaker. And then once we've got JSON in FileMaker, obviously you can do whatever you want with it. Alternatively, I did actually run that one on Mistral. This is basically using, it's the same process, just with Mistral versus OpenAI. So one of the questions about the difference between them is basically, where is the data going? And we all need to think about this when we're using large language models. Where is the data going? Where is the metadata going? Because the queries where we fed information to the LLM about the SQL query, we're still handing it the schema to our database. Not only that, but in some cases, you may actually be handing it criteria. So while you're not handing it a big chunk of data, like we were in the first examples, you're potentially handing it data. So this is just stuff we need to think about. And then performance, obviously. If you've got a system with a GPU, it's going to be a load faster, or OpenAI or Anthropic will be faster. So the next approach is retrieval augmented generation. And basically what we do here is we convert our query to a vector embedding, and we search for similar vectors. Then from that resulting set of vectors, we find our results, and then we use the LLM to convert that intermediate result to a final end text result, which all sounds a bit complicated. And the first question is, everyone's going to ask, is what's this vector thing? Basically, what you can do is with a chunk of text or an image, you can pass it into an embedding model, which is similar to an LLM in terms of how it works. And it produces a vector, a large string of numbers at the end. And if we look at a familiar analogy, if you think about color spaces in 3D, basically we're specifying colors by three numbers, say 255, 255, 255. What you can do is you can find similarity between those with the Euclidean distance, which basically is just sort of finding the minimum distance between them. And this is kind of a slightly oversimplified analogy, but so color spaces, it's in 3D, whoops, went the wrong way. With many more dimensions, what you can do is with text, basically look at the semantic similarity or the meaning of pieces of text and measure the distance between those as they're perceived by people. And in the case of the standard model that OpenAI is using, it's producing 1,536 dimensions in the vectors. So you can see that there are similarities between the text. So we've got a little boy is walking, a little boy is running, sort of a man is walking, and this is trying to simplify it down to 2 dimensions to view it. So that's a very simplified approach. So we take some example text from FileMaker. This was Joris's presentation from .fmp. His on how ChatGPT's prompts. This is what the embedding vector for that chunk of text looks like. Yeah, it's just a big vector of 1,536 elements. And what we do is that to find similarity, we do something similar. We try to find what are the closest vectors to that one in this huge many-dimensional space. And while we're doing that, we often need to search across a few million items, which that's the tricky bit. And what we do is we use vector databases for that. So there are a number of vector databases, things like Pinecone, Chroma, Weaviate. Basically, these are, some of them are open source, some of them are basically platform as a service, and fundamentally, they allow us to do that kind of query. And so it looks like this in action. So actually, this is not running in FileMaker, but I'll still demo it anyway. So what we've got is basically we enter some text, we do a search. This is going off to OpenAI. And what we've done is basically we've asked it the question, it's gone off and it's found the similar vectors. I asked it a question about fraud detection, and it's come up with all these pieces of text, basically from meeting transcripts that were discussing fraud detection and large language models. And it also gave a summary of all of the results. So in this case, you're saying it discusses the use of machine learning to detect fraud in e-commerce and the importance of tracking and monitoring. So that was an interview I did with someone who was chief data scientist at a very large e-commerce firm with hundreds of millions, if not billions, of users. So that was super interesting. And so anyway, so how this is working. I was going to do that. So that was my question. So what's happening here? There's 2 parts. Basically, we've got part 1 where what we need to do is we need to do the data extraction. And this isn't exactly matching, but essentially this was the demo I did. But what we do is we take our text, sorry, just a second. Yeah, in this case, we'd taken a text from image, extracted our structured data, had data in FileMaker. Those pieces of data were then passed to an embedding model. The embedding model is the model that generates the vectors. And I then store those embeddings in the vector database. In this case, it was Pinecone. So when we want to query that, which is part 2, what we do is we take our query from the user, we pass that query to the same embedding model and get the vector representation of it. We then search our vector database, which then returns, in this case, it returns a set of matching keys. So it's returning the database keys. And then what I'm doing is finding the records for those keys in the database, passing the information to the LLM. And that's not quite correct, actually. The LLM is not getting the embeddings. It is summarizing the data and then passes the summary back. So I will fix this. I'll fix this slide before it's posted. So basically with the retrieval augmented generation, we've got 2 parts. We've got data extraction, and then we've got the data querying. So those are 2 separate things, though they're working quite similar ways. Third approach, basically, are fine-tuned models. So OpenAI allows us to fine-tune models that they provide. And what that does is that retrains the parameters, uses transfer learning. It's quite slow. You can also train local models yourself, though that's quite difficult. And if you do not have a GPU, don't even bother trying. Very roughly, if we look at what we've got sort of two areas here, basically. Here we're talking about building a model, and over here we're using operating a model in a production environment. And they're quite different things. Operating the model in a production environment is basically all about reliability, performance, monitoring the system to make certain that it's working and that the models are still valid. Developing and testing the model is a very iterative process. It takes a lot of work, and it's more akin to a research project than a traditional IT project. You need to acquire the data, prepare the data, build the model, test the model, and when the model is working as you expect, then only then can you deploy it. The reason I'm showing this is because the example I'm going to show you is actually an example of where I did this all wrong. But I think that me doing it wrong was more instructive than if I showed you an example that worked. Hopefully nobody will walk out this time. OpenAI training data is in a JSON-L format. They provide the format you need to give them. And essentially what JSON-L format is just simply a list of JSON objects. So I built a FileMaker table where I basically set up my training data. I created 500 odd records of training data. I then had a calculated field that basically calculated the JSON-L format for each item. I then just did a summary field on them, exported them all. Needed to change the line endings, but then once I did that, then I was able to pass that into OpenAI to train it. That 500 records took about 2 hours on OpenAI to train. And if I tried to do that on my MacBook with a local model, it would be a lot more tricky to do, but also it would have certainly taken over a day, quite possibly a couple of days to do the training. So GPU is absolutely mandatory for training, which is why NVIDIA shares have been such good investments lately. Everybody wants NVIDIA. In fact, at the Python conference I was at recently, I spoke to someone from NVIDIA who said that their GPUs are in such demand that the internal developers have to basically book time on them. They can't get access to them because they're just selling them all. So here I'm going to do a demo of a fine-tuned model. And in this case, what I'm saying is you'll act as a chatbot that knows about the attendees of the EngageU conference, answer the question. If you don't know the answer, say, I do not know. And turnabout is fair play. My question is Ian Jempson in Antwerp at the same time as Charles Delphs? Why are they there? Okay, so we'll just run that. And I've selected my fine-tuned model. It's fine-tuned. It's more like a poorly tuned model, not a fine-tuned model. But if you look at the result, it's kind of interesting. If I'd stop clicking around. Because it comes back and it says in here, it says, yes, they're both attending the EngageU conference. So it was able to, from the training data, it was able to infer that we were both in the same town. Since we're both attending both at the conference, that's why we're in town. However, you'll see that what it's done is it repeated and repeated the same thing. And that up here, it says finish reason, length. So essentially what it was going to do was, I basically told it a limit on the number of tokens to use, and it just repeated the same answer again and again and again until it ran out of those tokens. So while the model gave a partially correct answer in one sense, it also gave quite a useful answer, useless answer, because what it's done there is it's just kept repeating things. And so I'll just show you what's happening here in terms of how it's working, and then I'll talk about why it failed. So we basically passed our query to the custom, fine-tuned model on OpenAI, and it returned JSON back to FileMaker. Great. So why did this go wrong? The fundamental problem was that the model was overfit to the training data. I also made several other mistakes, that I didn't test whether the concept was working on a small set of data. I didn't do a training and test data split, which is kind of really should have done. And fundamentally, it's running a completion model where what it's trying to do is to predict that next chunk of text, like we said earlier. And so that's exactly what it's doing. It's just completing the text. It's repeating it. It's doing exactly what it thought it should do. So the results of the training on OpenAI, you can basically, when you fine-tune a model, you can see the results of the training. What it's doing is it's showing us something called, showing us how many steps it's going through of the training, but it's also showing us a training loss. And the training loss is a measure of how accurate it's being in the training. And it's got nothing in the validation loss column because I didn't have any training. I didn't have the split for test and training data. But what I did was I uploaded this training data and used its defaults, because they basically set a bunch of sensible defaults that you cannot change unless you're using an API. So the API for training you can't use with curl. You have to either use their JavaScript or their Python APIs. But their web interface doesn't allow you to change all the parameters you need to do this properly. And the training loss of 0 is basically telling me that the predictions were exactly matching the data. And that's actually a bad thing, because it's just basically what it's done is just converged everything to return what it was trained on. So it's not generalizing the results. So I found this quite interesting, because initially I thought, oh, this looks easy. I'm just going to basically spit out the training data, upload it, process it, and then it's all good. But no, the training, even through the OpenAI interface for fine-tuning, looks like it does really need to go through the same process as other traditional machine learning training methods, basically a proper iterative development process of testing to make sure that it's great. Now, while it took a couple of hours to do this, the cost to do this, it cost like maybe $2 to train that model. So, but one of the big things is knowing, I think it's really important to know, is the model working? And that's quite a tricky thing. So I think fine-tuning models is something that people need to be really careful on. The other approaches, the passing in the queries and the prompt fine-tuning, prompting, prompt engineering, and the RAG approach, those I think basically people will be able to use quite easily. Yes, Russell?
I've got a bit of a problem with the concept of fine-tuning and training. When you're training, you pass data over, but don't you then have to say whether the result you get back is good or not, or how does the training occur?
What you do is in your training data, you provided examples of what you expect to provide as an input and what you expect to provide to see back as an output, and that's what it goes off. You also, because everything's changing so fast, they've got 2 different formats for data for different types of models that you can use for training. And essentially what you do is you say, this is kind of the context you want it operating in. Here's the input, and then here's the output, very, very roughly, but that's, and yeah, and I thought actually that I'd be able to get away with just kind of, what I provided was not a very good set of data. So anyway, I think for fine tuning, I think that's going to be something we're going to need to be really, really careful about. So the three main components we've talked about here are embedding models, vector databases, large language models. So large language models now, we've got, you know, substantially we've got OpenAI, we've got Anthropic, and then we've got Meta. Meta has open sourced their models, so a lot of the open source stuff is based on Meta, the Meta technology. OpenAI, you can host their models with Microsoft. Anthropic basically seems to be the choice of Amazon. So Anthropic models are now available in some but not all Amazon data centers. And what I was trying to do was to build up an image of where does the data go. So we've got data, we've got metadata, and then we've also got the question about, is this data in the country? Because if you're passing your data to OpenAI, you don't really know where it's going. So what I've done is I've broken it up into three chunks. At the bottom, we've got hosted, fully hosted stuff. The middle is basically if you're hosting in a data center, so if you're on AWS, and then local. So if you're running them locally, obviously that's in your control, but you're then also managing servers again. Hosting on things like AWS, the three components, the LLM with Amazon. Amazon have just, I expect very soon Amazon's going to roll it out across the board. But if you're in Europe and you want to go with Amazon for their product, it's called Bedrock, and allows you to choose the models. And Bedrock is only available in the Frankfurt data center at the moment. And if you want to use an Anthropic model, you basically need to fill in a little form saying, why do you want to, you need to provide Anthropic with your use case to get approval to use their models. Embedding models, basically, again, you would choose the data center. And so the question of whether it's in country is based on the data center you choose. Same thing for the vector store. It's a little bit different with the hosted models. So the LLMs, basically, from what I can see, you've got no control over where your data is. That will probably change. Anthropic are trying to be, the impression you get is that they're trying to be very responsible corporate citizens. So they may well provide the ability to say where your data is going. The embedding models, if you're going hosted, that's exactly the same as the LLM. Vector stores are a little bit different. Pinecone allow you to choose which data center your vector index sits in. So you do have some control over whether it's in your country or not, but the data and the metadata is still in their data center somewhere, wherever that may be. So if we go back to the pace of change, basically we're looking at rate of change of technology, which is really, really fast, product requirements, legislative requirements are changing. So the American government, the American president had a recent order on AI, and that's going to affect what the U.S. government buys, and because the U.S. government is probably the biggest customer, that's going to in turn drive what people are providing. So most firms probably will fall in line with what they're doing in that regard. And then competitive pressures. OpenAI thought for a while they had this all to themselves, and once the open source models came out, it's clear they don't. So everything's changing really, really fast. And yeah, it's basically, if I was looking at sort of the rate of change, continuous versus discontinuous, kind of right now, everything is high rate of continuous change. And that's basically led to things like, like APIs changing really, really fast. But the other thing here is that if you're doing any kind of fine tuning of a model, you need to think about the environment you're fine tuning for. That one of my interviews with the fraud detection, they described it as an arms race. They're building and deploying models on a weekly basis because the fraudsters are doing the same. The fraudsters are trying to probe their defenses against fraud, and they have to be reactive. So they're basically having to build models really, really fast that are also reliable, but also don't adversely affect their customers, because if they're turning down sales because it looks like fraud, but it's not, that's a problem. And one of the issues they said was that when people who are using shopping bots, they're actually valid purchases, but the behavior seems very, very similar to AIs employed by fraudsters. So shopping bots were often being blocked from making valid purchases. So the rate of change driven by that business environment was very, very high. And that's not the case. One of the other people I interviewed, they basically were doing predictive maintenance models for gas turbines and wind turbines. Very slow rate of change. They'd written their models years and years and years ago, and very little updates needed. Everything just works. So we need to bear these things in mind when looking at, do we implement models, particularly fine-tuned models, where things can be expensive and difficult to change. And then monitoring the systems to ensure that they're performing as we expect is really, really important as well. So that kind of comes back to that. So anyway, thank you for your time. Do you have any questions? Yes.
You mentioned that you're looking forward to the FileMaker implementation, because then we can hand off the changes that occur to FileMaker. But
some areas.
Sorry?
In some areas, hopefully.
Yeah.
Actually, that's a question for Doug. I can't really answer that.
No. But I was just wondering, don't you think then if we hand it off to FileMaker, then that we would be stuck with the problem that something changes in the AI world, but we have to wait for the next FileMaker release before it's going to be fixed in FileMaker. Well, if you do it yourself, you can indeed change your curl or something else, and you can continue.
Yes, that's an excellent point. And you're, yes, probably right. I think sorry. Yes, Joel.
Given the difficulties in the rate of change, how soon, or do you see it happening at all, do you think it'll be useful in a solution and usable in a solution?
I think that comes down to what the business case is for it. That if there's a business case, let's take the example of if you've got product descriptions that you want to come up with a product write-up that is in the company's style to go up on a website. That's the kind of thing that you'd be able to implement now. And it's kind of a low technical risk. It's like you're not going to break the company or bankrupt the company. If that goes wrong, you can just basically go back to the old way of doing it. But it has the potential to save a lot of time. If a company's got, say, 5,000 products, to basically generate those summaries or those write-ups in the matter of a few hours, and you'd be able to do that on an ongoing, regular basis as well. So so there are valid, genuine use cases. But the thing is, it all has to be driven from the business, a genuine business need, not just because I want to implement AI. That's not a way to. One other thing I'll just mention is that The person I interviewed about the fraud detection, they were saying that actually, from their experience, most AI models that are built are never deployed. They said that they basically just had a vast number of models that people had built, never ever got deployed, either because they didn't work quite right or they took too long to get ready, and basically their time had passed by the time they were ready. So it's... So any other questions? Okay, thank you very much.